On August 4, 2025, the Kennedy Space Center became the stage for a breathtaking event that drew thousands of spectators from around the world. Excitement buzzed in the humid Florida air as anticipation built for what was about to unfold. A SpaceX Falcon 9 rocket gleaming in the dawn light soared skyward in a blaze of fire and thunder, carrying 28 Starlink satellites into orbit. The crowd erupted in cheers as the engines ignited, marking another milestone in the journey to connect the globe. Imagine a skyscraper roaring to life, powered by millions of controlled explosions working in perfect harmony. The sheer force unleashed in those first seconds is enough to shake the earth and leave hearts pounding. The ground trembled beneath everyone's feet, the air buzzed with energy, and for a few moments the world watched in collective awe as human ingenuity defied gravity once again. But this launch was more than just a spectacle of fire and engineering. It was a crucial step toward global connectivity, a mission with the power to change lives far beyond the launch pad. Billions of people around the world still lack reliable internet access, and this mission aimed to bridge that digital divide. Each satellite launched brings us closer to a future where everyone, no matter where they live, can connect, learn, and thrive. As Falcon 9 climbed higher, it carried not just hardware and technology, but hope for a more connected, informed, and empowered world. After successfully deploying its precious cargo of satellites, the rocket's first stage performed its signature move, a controlled descent back to Earth, guided by precision engineering and years of innovation. It landed perfectly on the Droneship, a shortfall of Gravitas stationed in the Atlantic Ocean, a feat that once seemed impossible but is now becoming routine thanks to relentless progress. This flawless landing showcased the power of reusable rocket technology, making spaceflight not only more sustainable and environmentally friendly, but also dramatically more affordable for future missions. The mission was a symphony of power, precision, and purpose, a testament to what humanity can achieve when vision and technology come together. It's not just about reaching space, it's about making space work for everyone on Earth, ensuring that the benefits of exploration and innovation are shared by all. Each launch builds the future, one step at a time, laying the foundation for a world where opportunity and information know no boundaries. The August 4th mission reminded us of our boundless potential, and that with every launch, we move closer to a future where the sky is not the limit, but just the beginning. Let's break down the launch moment by moment and see how each phase brings us closer to the stars. At exactly 7:15 p.m., Launch Complex 39A came alive with anticipation. The Falcon 9's 9 Merlin engines roared to life, lighting up the night sky and sending a column of fire and smoke billowing beneath the rocket. With a thunderous rumble, the vehicle began its ascent, leaving Earth behind and embarking on its journey to orbit. In just 2.5 minutes, the first stage had completed its crucial job, propelling the rocket through the thickest part of the atmosphere. Then, main engine cutoff, known as MECO, occurred, and the engines fell silent for a moment. The booster separated cleanly, beginning its own journey back to Earth, while the second stage ignited and pressed on, carrying its precious cargo of satellites higher and faster into space. The returning booster performed a series of carefully timed burns, using its titanium grid fins to steer through the upper atmosphere. These fins acted like wings, guiding the booster as it slowed and aligned itself for landing. Just 8.5 minutes after liftoff, the booster touched down softly on the Droneship waiting at sea. This marked its 14th successful flight, a testament to the reusability and reliability of SpaceX's technology. Meanwhile, the second stage continued its journey, carrying dozens of Starlink satellites into low Earth orbit with the blue curve of Earth as a breathtaking backdrop. At the perfect moment, the satellites were released from their cradle, drifting away gently like dandelion seeds caught in a cosmic breeze, ready to begin their own missions. Each satellite would then use its own tiny thrusters to maneuver into its final orbit, 550 kilometers above Earth, joining the ever-growing Starlink constellation. The entire sequence, from ignition to satellite deployment, was a masterclass in engineering, teamwork, and choreography. Every step planned and executed with care. Every phase, from the fiery liftoff to the pinpoint landing, was a display of precision and innovation, pushing the boundaries of what's possible. This is how modern spaceflight turns science fiction into reality, making dreams of routine access to space come true before our eyes. The August 4th launch was flawless from start to finish, a shining example of how far we've come on our journey to the stars, and a glimpse of the future that awaits. What are Starlink satellites? Think of them as compact internet routers orbiting Earth. Each is about the size of a coffee table, working together in a vast constellation. Their mission: deliver high-speed, low-latency internet to even the most remote places. With over 7,500 satellites now in orbit, Starlink ensures near-global coverage. Unlike old satellite systems, Starlink's proximity to Earth slashes lag, making video calls and gaming smooth. The impact is real. Remote communities now access education, healthcare, and emergency services. Starlink's mesh network uses lasers to pass data between satellites at light speed, reducing reliance on ground stations. This enables coverage over oceans and polar regions, connecting people everywhere. The August 4th launch expanded this web, bringing reliable internet closer to everyone. Starlink is building a digital bridge across the planet. The Falcon 9's greatest trick? Reusability. It's a feat that has redefined what's possible in spaceflight, turning what was once science fiction into everyday reality. For decades, rockets were single-use machines, launched once, then discarded into the ocean or left to burn up in the atmosphere. But SpaceX changed the game forever. Now the first stage booster, the most expensive part of the rocket, lands itself with precision, ready to fly again. This breakthrough slashes costs and makes frequent launches possible, opening the door to a new era of space access. Guiding the booster back are titanium grid fins, which steer it through the atmosphere at supersonic speeds. These fins withstand extreme heat and stress, ensuring pinpoint landings. The rocket carefully reserves just enough fuel for 3 critical maneuvers: the boost back burn to reverse course, the entry burn to slow down, and the landing burn for a gentle touchdown, all orchestrated by advanced onboard computers. Even the payload fairing, the protective nose cone that shields satellites during launch, is recovered and reused, saving millions of dollars with every mission and reducing waste. Take the August 4th booster, for example. It had already flown 14 times, each mission adding to its legacy and proving the reliability of SpaceX's approach. At the heart of it all are the Merlin engines, designed for multiple restarts. This capability is crucial for the complex landing maneuvers that bring the booster safely home. After every flight, SpaceX engineers meticulously inspect, refurbish, and upgrade the hardware. Each launch is a chance to learn, improve, and push the boundaries of what's possible. This relentless cycle of flying, learning, and refining has transformed Falcon 9 into the workhorse of modern space exploration, launching satellites, cargo, and even astronauts with unmatched reliability. Reusability isn't just an innovation, it's a revolution that's changing the economics and possibilities of space forever. Every recovered part, every successful landing, brings us one step closer to affordable, routine space travel for all of humanity. This is science in action, progress made real, one spectacular landing at a time. How does Starlink deliver internet from space? It starts with a user terminal, a smart dish that auto-tracks satellites overhead. The dish sends requests up, satellites beam data back down. Starlink's low Earth orbit means signals travel faster, reducing lag to just 20–40 milliseconds. Each satellite unfolds a solar panel for power and uses ion thrusters for precise movement and safe deorbiting. The real breakthrough: optical space lasers. Satellites pass data between each other at light speed, minimizing ground station dependence and enabling global coverage. A central network center manages the constellation, routing traffic efficiently. When you request a website, your signal may hop between satellites before reaching the ground. The system brings the world's information to your home in a blink. It's a seamless, high-tech relay from sky to screen. Starlink turns the cosmos into a digital highway. Starlink's biggest impact? Bridging the digital divide. In places where cables can't reach, a clear sky is all you need for high-speed internet. This opens doors for education, business, and healthcare in remote regions. Starlink empowers students, entrepreneurs, and families to connect and thrive globally. Its space-based infrastructure is resilient, vital during disasters when ground networks fail. Starlink has already restored communications after hurricanes and wildfires. With every launch, the network grows stronger and more reliable. Competition from Starlink pushes all providers to improve. Universal internet access is becoming a reality, not a luxury. Revolutionary tech brings challenges, and Starlink is no exception. Thousands of satellites crowd low Earth orbit, raising concerns about space debris and collisions. SpaceX plans for safe deorbiting, But managing space traffic requires global cooperation. Astronomers worry about bright satellites interfering with telescope images, though SpaceX is working on solutions. Occasional service outages still happen as the network matures, but reliability is improving. Navigating international regulations is another hurdle. Each country has its own rules and concerns. Gaining permission to operate globally is a complex, ongoing process. These are the growing pains of a truly global system. Balancing innovation with responsibility is key. Starlink's journey is as much about solving problems as it is about connecting the world. The August 4th launch is just the beginning. SpaceX is preparing to launch larger, more powerful Gen 2 Starlink satellites on its next-gen Starship rocket. These new satellites will boost network capacity and speed dramatically. Starship, designed for full reusability, will launch hundreds of satellites at once, accelerating global coverage. The future of Starlink is tied to Starship's success. Revenue from Starlink will help fund SpaceX's ultimate goal, making humanity multi-planetary. Today's launches lay the groundwork for tomorrow's missions to Mars. In the near term, expect more launches, better user terminals, and expanded service worldwide. Each mission pushes the frontier further. SpaceX is turning bold visions into reality, one launch at a time. The August 4th launch was more than a technical triumph. It was a leap toward a connected world. It brought us closer to bridging the gap between the connected and the unconnected. For students, businesses, and families, it means new opportunities and stronger bonds. Science and vision combined to solve real-world problems. Falcon 9's reusability has made ambitious projects like Starlink possible. This mission inspires us to question limits and pursue better solutions. Each satellite launched is a thread in a global web of hope. Challenges remain, but the promise of universal connection is powerful. We're living in an era of extraordinary progress. When we reach for the stars, we find ways to improve life on Earth. The journey continues, one launch, one connection at a time.